Hello everyone, welcome to the next set of video notes in our sequence and series unit. Today we're going to talk about this idea of partial sums. Let me write that down. So with partial sums, it's nothing crazy. It's pretty simple. It pops up when we're dealing with infinite series. So right now in our past unit, we only looked at finite series, so we're looking for the sum of a specific uh, number of terms in a sequence or series. So with partial sums, it's a specific technique that you use, and we'll put it to more use next week. We just kind of want to practice the idea this week. So if I give you a sequence like this, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus so on and so forth. This is going to keep going. And there really is no way to actually evaluate what this infinite sum would be. Okay, so this, if we were to put it all together in summation notation, would look something like this. N equals 1 to infinity of n. And you just add them all together. So that's what this is here. Okay, and this would be S sub n. Right? The idea of partial sums is that you can sum together some of it. So if I wanted to find, whoa, I don't know where that line came from. I also can't erase it, which is very interesting. Whatever. We'll just deal with this line here. That's concerning. Oh, there it goes. Get rid of it. I'm leaving that in. I'm not even going to restart this because I started so good that time. Okay, but anyway, so we got this thing here. It's really important. The idea of partial sums lets us kind of break down and see what's going on. So when you take a partial sum, you're taking the sum of a certain number of terms. So if I want to find S sub 1, the sum of the first term, that's just 1. Okay, that's 1 plus, well, it's just itself, so it's just 1. S sub 2 will be the sum of the first two terms, so 1 plus 2. This is just 3. S sub 3 would be equal to the sum of the first three terms, so 1 plus 2 plus 3. It's just 6, and so on and so forth. And that kind of gives you your, this is what a partial sum is. So if I wanted to find S sub 8, I'd want to find the sum of the first 8 terms. So what this would be this expression here, n equals 1, and I'd want to find the sum of the first 8, so I put an 8 up there. This is something that you know how to evaluate. This is just an arithmetic sequence or series that you're going to evaluate, so you use the formulas that you've done so far. On that note, remember your formulas. Arithmetic are a sub n is equal to a sub 1 plus d times n minus 1. And then S sub n, the sum of an arithmetic series, finite arithmetic series, which this is now finite because I'm doing the partial sum up to 8, is going to be n over 2 times a sub 1 plus a sub n. Okay, and then you also have your geometric stuff right here. And we know our a sub nth term is equal to a sub 1 times r to the n minus 1. We know our S sub n is equal to a sub 1 times 1 minus r to the nth divided by 1 minus r. Okay, and these are only infinite, and that's what a partial sum is. It's asking you to find the value of a finite series from an infinite series. And these things can get really, really cool. When we look at this sum up here, so this one right here, if I were to keep doing this, I can get a feel for what's happening with this infinite series. If I keep adding on another number, so this is always going to keep getting bigger. If I wanted to find S sub 100, I'd be adding 100 things together. This would be big. And then if I wanted to find S sub 1000, it would be even bigger. Okay, just keep getting bigger and bigger and bigger and bigger and bigger. And it has no sum because you never actually get to a number. And that's a really important idea that we're going to talk about next week. And this is why we use partial sums. For instance, if I looked at something that was a little bit more interesting, a series like this, so I've said s is equal to 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus so on and so forth. This here would be a little bit more interesting because I'm adding smaller amounts each time. And if you look at like a square like this, and I break it up into two, so this is my 1, and if I add to this half the square, okay, I filled in that, then I fill in a fourth of my remaining square, and then I fill in an eighth of my remaining square, and then a 16th of my remaining square, and then a 32nd of my remaining square, and so on and so forth. You can see that I'm filling up this block here, and my final answer, if I did this sum, should be equal to 2, because I keep adding up a little bit at a time. And you can see this if you calculate partial sums. So s sub 1 is equal to 1. S sub 2 is equal to 1, don't need that line, 1 plus 1/2, which is equal to 3/2. And then s sub 3 is equal to 1 plus 1/2 plus 3/2, or it's going to be 3/2 plus 1/4, which is going to be 6 out of 4 right here, so 7/4. 7/4 right there. And then I can see s sub 4 is going to be equal to 7/4 plus 1/8. 7/4 plus 1/8 is just, well, this is double this, so 14, so 15/8 right there. Okay. And then if I keep going, I'm gonna keep getting closer and closer to 2. You can see this is really close to 2. It's almost 2. There's only 1/8 left, and then s sub 5 is equal to 15/8 plus 1/16. This is going to be equal to 31/16, which is even closer. So you just keep getting closer and closer to 2. And this is what partial sums can let you see. They can let you see these values here. So all you're going to do in the IXL is practice adding. Use a calculator. If you need to use these formulas, use them. This is the real reason why I did these notes. You guys should know these formulas and know how to operate and use them and all that. That's all that we're doing today. You're going to practice that. I also found a fun video that I want you guys to watch, because we'll talk about it in the future. And it's a really nice glimpse as to why mathematics is so cool. Thank you guys.